SQL is one of the most valuable skills for anyone working with data, software development, analytics, or databases. The first step is creating a table to store our product data. In SQL, we use the create table statement to define the structure of a table, including its columns and data types. In this example, we'll create a table called products that stores information such as the product ID, name, category, price, and available stock quantity. The product ID column is designated as the primary key, ensuring that each product has a unique identifier. Now that we've created the products table, let's add some data using the insert into statement. The column names inside the parentheses specify where each value will be stored: product ID, product name, category, price, and stock. The values keyword contains the actual records we want to insert. Each set of parentheses represents a single row in the table. For example, the first row adds a laptop in the electronics category with a price of $1,200 and a stock quantity of 10. The remaining rows add a mouse, desk, and chair with their respective categories, prices, and stock levels. One of the advantages of this syntax is that we can insert multiple rows with a single query, making data entry faster and more efficient. After running this statement, our products table will contain 4 product records that we can use for querying, filtering, sorting, and other SQL operations throughout the tutorial. Now let's learn how to modify existing data using the update statement. The update command is used when you want to change the values of one or more records that already exist in a table. In this example, we're updating the products table and changing the value of the price column to 30.00. The where clause is extremely important because it specifies which row should be updated. Here, where product ID equals 2 ensures that only the product with an ID of 2 is modified. Before the update, the mouse product had a price of 25.50. After executing this query, its price becomes 30.00, while all other products remain unchanged. Let's update multiple columns at once using the update statement. In this example, we're modifying both the price and stock values for a specific product. The set clause allows us to change one or more columns by separating them with commas. Here, we're increasing the laptop's price from 1,200.00 to 1,250.00 and reducing its stock quantity from 10 to 8. The where product ID equals 1 condition ensures that only the laptop record is updated. Without the where clause, every product in the table would receive the same price and stock values, which is usually not what you want. This is a common real-world operation when product prices change or inventory levels need to be adjusted after sales or restocking. In this example, we're updating multiple rows at the same time. Instead of assigning a fixed value, we're using an expression, stock equals stock plus 10. This tells SQL to take the current stock value of each matching product and add 10 to it. The where category equals electronics condition limits the update to products in the electronics category. Based on our sample data, this would affect the laptop and mouse records only. For example, if the laptop has a stock of 8 and the mouse has a stock of 50, after running this query their stock values would become 18 and 60 respectively. Products in other categories, such as furniture, would remain unchanged. In this example, we're updating the price of every product in the table by increasing it by 10%. Instead of setting a fixed price, we're using a mathematical expression, price equals price 1.10. The value 1.10 represents 110% of the current price, which means each product's price is increased by 10%. SQL calculates the new value for every row and updates the price column accordingly. Notice that this query does not include a where clause. As a result, the update affects all records in the products table. For example, a laptop priced at $1,250 would become $1,375, while a chair priced at $120 would become $132. Now that we've inserted and updated some data, let's retrieve the records using the select statement. The asterisk is a wildcard that tells SQL to return all columns from the table. In this example, select from products fetches every row and every column from the products table, including the product ID, name, category, price, and stock quantity. When you execute this query, the database returns the complete contents of the table. In the terminal, you can see the result displayed as rows of data, making it easy to verify that your inserts and updates were applied correctly. This is often the first query developers run after modifying data to confirm that the table contains the expected values. Let's refine our query to return only specific information from the table. Instead of selecting all columns, we can choose exactly what we want to see. In this example, we're using select product name from products to retrieve only the names of the products. This means SQL will ignore all other columns like product ID, category, price, and stock, and return just a single column containing product names. This is useful when you only need specific data instead of the full dataset, which helps keep results clean and easier to read. For example, you might only want a list of product names for a drop-down menu, report, or quick overview. When you run this query in the terminal, the result will be a simple list of all product names stored in the table. Let's expand our query to retrieve multiple columns at once. Instead of selecting just one field, we can specify a list of columns we want SQL to return. In this example, we're using select product name, price from products to fetch both the product names and their corresponding prices. This allows us to see key information side by side without displaying unnecessary data like product ID, category, or stock. When SQL executes this query, it goes through each row in the products table and returns only the product name and price columns for each product. For example, you might see entries like laptop 1375.00 inches and chair 132.00 inches depending on the current values in your table. This type of query is very common when you want a clean, focused view of important fields, such as showing product listings on a website or generating a simple price report. Let's add filtering to our query using the where clause. The where clause allows us to retrieve only the rows that meet a specific condition. In this example, we're using select from products where category equals electronics to return all columns, but only for products that belong to the electronics category. SQL will scan each row in the products table and check the category value. If the category matches electronics, that row is included in the result. Otherwise, it is excluded. In this example, we're using select product name, stock from products where stock 20 to find all products that have a stock quantity greater than 20. SQL checks each row in the products table and compares the stock value. If the value is greater than 20, that product is included in the result. Otherwise, it is excluded. In this example, we're using select product name, price from products order by price desk to sort the products by price in descending order. The desk keyword means highest to lowest, so the most expensive products will appear first. SQL takes all the rows from the products table, compares the price values, and then arranges them from the highest price down to the lowest. For example, a laptop would likely appear at the top of the list, followed by lower priced items like desk, chair, and mouse. If we use ASC instead of desk, the results would be sorted in ascending order, lowest to highest price, which is the default behavior if no sorting direction is specified. Let's look at how to remove duplicate values from a query using the distinct keyword. This is useful when you only want to see unique values in a column instead of repeated entries. In this example, we're using select distinct category from products to retrieve a list of all unique product categories stored in the table. SQL scans the category column and filters out duplicates. Even if multiple products belong to the same category, like electronics or furniture, each category will only appear once in the final result. Let's learn how to rename columns in a query using the as keyword. This is called aliasing, and it helps make results easier to read or better suited for display. In this example, we're using select product name as product, price as cost from products to rename two columns in the output. The original column product name will appear as product, and price will appear as cost. In this example, we're using select from products limit to retrieve only the first two rows from the products table. SQL executes the query and returns all columns, but instead of showing the entire table, it stops after returning just two records. The first rows are determined by the database's default order, unless you use order by to specify a sorting rule. In this example, we're using select count as total products from products to calculate how many total records exist in the products table. The count function counts every row in the table, regardless of whether columns contain null values or not. It simply returns the total number of rows. We also use as total products to rename the output column so the result is easier to read. Instead of showing an unnamed column, the result will clearly display as total products. In this example, we're using select AVG price as average price from products to compute the average price of all products in the products table. SQL takes all values in the price column, adds them together, and then divides by the total number of rows to produce a single average value. The result is returned as one number instead of a list of rows. We also use as average price to rename the output column so the result is clearly labeled. This makes it easier to understand when viewing query results in a terminal or report. In this example, we're using select max price as highest price, min price as lowest price from products to get both the most expensive and least expensive product prices in a single query. The max price function scans all values in the price column and returns the largest one, while min price returns the smallest one. SQL processes all rows in the table and calculates these two summary values at the same time. We also use aliases as highest price and as lowest price to make the output more readable, so the results are clearly labeled in the terminal or report. Now let's run different select statements on the products table. The terminal updates to show the result of each select statement based on the conditions and columns you choose. Now let's use the delete statement to remove data from the products table. The delete statement is used to remove one or more rows from a table. We can delete a specific product by its identifier, or we can delete multiple products by applying a condition based on values in the table. For example, we can remove a product using a condition on its price, such as deleting items that fall below a certain price range. This allows us to clean up or manage data based on business rules, instead of manually removing records one by one. After running a delete query, we can use a select from products statement to check the result. In the terminal, you will see that the deleted products no longer appear in the table. This video explores SQL and shows you how to use it to create, manage, analyze, and delete data in databases.